All right, now we're going to pull all these pieces together and we're actually going to draw a parabola on the coordinate plane, draw the graph, okay? So let's get moving with this. Okay, so we're going to start very simple. This is the parent graph. You've seen it before. We should be able to sketch this in our sleep, but I want to use it to identify A, B, and C and just do all the components. So A is 1, B is 0, C is 0. A is a positive number, so it's going to open up, which means that my curve is going to go like this. And that means my vertex is going to be a, excuse me one second. My vertex is going to be a minimum. The y-intercept is 0C, which means it's 0, 0. The axis of symmetry and the x-coordinate of my vertex is negative b, which is 0, over 2, which is 0. Now I plug this number into my equation to find the y-coordinate of my vertex. So I'm going to plug in 0 for x, square it, and I get 0 in this case. So my vertex is 0, 0. They won't always be that easy. The domain we learned, because I can pick any x's that I want, it's going to be negative infinity to positive infinity. Because the range, because this is a minimum, my y-coordinate is going to be my smallest number, and then it's going to go off to positive infinity. So I get 0, comma, positive infinity. And now I'm going to make a table. Well, I know that 0, 0 is my vertex. I put that in the center, just like we did with the absolute value. Okay? And then I'm going to pick a point to the right. So the y equals 1 squared. So that's going to be 1, 1. And pick a point to the left. Y equals negative 1 squared. So that's going to be, remember when you square a negative number, if there's not another negative out in front, it has to go positive. Negative 1, 1. So we would have a point here, a point here, a point here, and then I know if I plug in a 2, I'm up at 4. If I plug in a negative 2, I'm up at 4. So my curve is going to go like this. Here's my parabola, just like that. See how I have a U at the bottom? Make sure you get a U at the bottom. Okay, let's try another one. This is a reflection of the parent curve because there's a negative out in front. So that means A is negative 1. Now I know this feels different than when we're in vertex form for the transformations, but keep your signs with your coefficients for this, okay? B is 0, C is 0. This is going to open down, and that's because A is negative. So it's going to kind of go like this. That means my vertex is going to be a maximum. Where it bends, it's going to be the highest point. That's going to affect my range. My y-intercept is again 0, 0. The axis of symmetry and the x-coordinate of my vertex is 0 over 2, which is equal to 0. So let's go ahead and draw that in. I'm going to use a red line for that. I didn't do that on the first one, but this is a real important line to put on there. Axis of symmetry, x is equal to 0. Now let's plug it in to find the y-coordinate. Again, this one is going to be 0 squared, so we get 0, 0. My domain is always negative infinity to positive infinity. The range, this is my y-coordinate is my maximum, so that means it's going to go negative infinity to the y-coordinate of my vertex. So that's going to be negative infinity to 0. And then we're going to make a table. And we're going to be careful how we plug this in. So if I plug in a 1, this is my vertex. I've already calculated it. No need to do it again. 0, 0. Just put it in that table. And then I'm going to go y equals the opposite of negative 1 squared. Well, negative 1 squared, that's positive 1, but if you take the opposite of it, you get negative 1. And then I'm going to plug in negative 1, and I'm going to go y equals the opposite of negative, that should be positive 1, but that doesn't change. Sorry about that. Negative 1 squared is positive 1, and the opposite of that is negative 1. So this is negative 1, negative 1. Let me talk through this one more time. If I plug in a positive 1 squared is positive 1. Then I take the opposite of it. That's what this negative out in front tells me to do. So I get 1, negative 1. And I am here, and here, and here. And then I know if I plug in a negative 2, I'm going to get a negative 4. And if I plug in a positive 2, that'll just give me more points to get my curve nice. And that's it. All right. Okay, this one has more components to it, so let's go through it. My A is negative 2. My B is negative 4. My C is positive 4. This is going to open down again because A is negative. So down. If I open down, then my vertex has to be a maximum. So my y-coordinate has to be the highest point. My y-intercept is going to be 0, C, which is 0, 4. I'm going to find the axis of symmetry, which also gives me the x-coordinate of my vertex by using the formula negative b over 2a. So I get the opposite of negative 4. That's 4. And then 2 times negative 2. So I get 4 over negative 4. That's negative 1. So here is, I'm going to do it in red. Here is my axis of symmetry. My phone's going off. Sorry about that. Okay. Now I'm going to plug it into my equation to figure out what my y value is. So I'm going to go negative 2 times negative 1 squared minus 4 times negative 1 plus 4. I'm going to keep working this way. This negative 1 squared is 1. 1 times negative 2 is negative 2. Negative 4 times negative 1, that's plus 4. And then I have plus 4. So this is 4 plus 4 is 8 minus 2 is 6. So my ordered pair for my vertex, we label it with a V, is negative 1, 6. So let's put that on the graph. Here it is right here. There's my vertex. Okay? The domain is always negative infinity to positive infinity. The range, this is going to be a maximum. So this means that the y-coordinate of my vertex has to be my highest value, and everything else is going to go below it. If you don't see that like right now, graph it and then come back to your range. But so let me do it that way for you this next time. Hopefully I'll remember. Okay, so I'm going to put negative 1. This is my vertex. Negative 1, 6. Okay. And then I have 0, 4. This is my y-intercept that I've already calculated. Okay. And then by symmetry, I'm going to have negative 2. I'm going to just say symmetry. Symmetry, negative 2, 4. So here's 0, 4. Okay, so look, I moved one space to the right of the axis of symmetry. So that means if I move one space to the left, I have to have a point right there. So it has to be negative 2, 4. And then I'm going to plug in a 1, and it's in the way. If I plug in let's try this one, -3. Let's plug in a -3. So y is going to be -2. -3 squared is 9, minus 4 times -3 plus 4. Okay, so this is positive 12 plus 4 is positive 16 minus 18. So I get -3, -2, which means that I'm also going to get, if I count two spaces, so here's 1, 2, and I'm at -2. If I count two spaces, 1, 2, I'm also going to be at -2. So this is going to be 1, -2. Okay, I used symmetry to get there because my controls were in my way. And there we go, just like that. This should go through this point right here. Sorry about that, I got a little excited. Okay, last one. A is a half. Ooh, yuck, we have a fraction. That's all right, don't worry. B is 3. C is -6, right? A is positive, so it's going to open up. So look, my vertex has got to be a minimum. My y-intercept is 0, C, 0, -6. If I'm going to find my axis of symmetry, which is also the x-coordinate of my vertex, I'm going to calculate -b over 2a. So that's -3 over 2 times a half. So that's -3 over 1, which equals -3. And then I'm going to take this number and I'm going to plug it into my equation. So I have 1/2 times -3 squared, which is 9, plus 3 times -3 minus 6. So this gives me 9/2 minus 15. Well, that's going to be 9/2 minus 30/2. So my vertex is 3, -3, -21/2, which is -10.5. So I'm going to use 2's here. This is a 2, and this is a 2. Okay, and then I'm going to draw my axis of symmetry in red, which is -3. So here is -2, -4. Here's -3. Don't worry about the solutions. We'll talk about that tomorrow. And I'm going to put my vertex in. -3, -10.5. So here's -2, -4, -6, -8, -10. So I'm about right there. -10.5. My domain is always -infinity to +infinity. My range, okay, I'm going to come back and I'm going to do both those ranges. Sorry. All right, so here I'm going to plug in. I have -3. That's my vertex. So I get -3 and -21 over 2, which is -10.5. I'm going to plug in 0. That's my y-intercept. And that's going to give me 0, -6. And then I'm going to plug in -6 because that's the same distance. So this is symmetry. So this is going to be -6, -6. So here I am. 0, -6. Here we go. And then -6, -6. And then let's pick something like -8. Let's pick -8. 64 plus 3 times negative 8 minus 6. So let's see, what do we have here? That's a minus. So I have negative 24 and negative 6. That's negative 30. And this is positive 2. So I get negative 8, 2. Okay, so that means I'm up here. Which means by symmetry, I'm also going to be at 2, 2. So here we go, just like this. And that's it. I'm going to have a worksheet for you for our daily assignment. That would be daily assignment. Oh, and I need to go back and do those ranges. Okay, let me go back. All right, so look, this is opening up. So that means I'm going to be, my smallest value is going to be at negative 21 halves up to positive infinity, because this is my smallest value. And my largest value just keeps going up and up and up and up. And on this one, my largest value is my vertex, so that means I'm going to go from negative infinity to 6, just like that. Okay, now I'm done. I'll see you tomorrow.